also depends upon the bias of whomever the person is who constructed said AI model when it comes to the language model AIs, which is what ChatGPT is. Um, so yeah, that's just my thoughts. But apparently, ChatGPT, I don't know. I'd have to look at the inner workings of it. But if it's an associative learning AI, like most advanced AIs tend to be, apparently ChatGPT has a pigeon brain. Alrighty. So folks, I have recorded my thoughts on ChatGPT, but I haven't put it up yet. And in part, I haven't put it up yet because I actually want to do a little bit where I just sit down, recording some questions I ask to ChatGPT and things that I ask it to do related to science and things going on in science and what have you, and just get a sense of what it does or what it looks like, and just record it on the fly rather than just relying on screenshots or something like that. So I'm intent on doing that, but I may have to do that this weekend, and I want to put those two videos and release them together. So or in the same week anyway. So I may release that ChatGPT video that I did last week, that I did this week, next week. So, and pair it with the other one that I want to record. But anyway, in the meantime, speaking of AI, I figured this might be fun. Pigeon versus AI. It's amazing and interesting sometimes what kind of research can come about. And in this case, they are asking, I have no idea what level of significance this question is. I mean, where this comes from, but yeah. Pigeon versus artificial intelligence. Can the pigeon, the humble pigeon, match wits with AI? Okay. Can a pigeon match wits with artificial intelligence? Researchers tested pigeons' learning abilities and concluded that birds employ the same basic process called associative learning as the most advanced AI technologies. So you gotta remember, AI, one of the things it's about trying to do is mimic the human brain a bit. So in a new study, psychologists at the University of Iowa examined the workings of the pigeon brain and how the brute force of the bird's learning shares similarities with artificial intelligence. The researchers gave the pigeons complex categorization tests involving high-level thinking, such as using logic or reasoning, would not aid in solving. Instead, the pigeons, by virtue of exhaustive trial and error, eventually were able to memorize enough scenarios in the test to reach nearly 70% accuracy. Learning by trial and error, right? The researchers equate the pigeon's repetitive trial and error approach to artificial intelligence. Computers employ the same basic methodology, researchers contend, being taught, quote unquote, how to identify patterns in objects easily recognized by humans. Granted, computers, because of their enormous memory and storage power and growing ever more powerful in these domains, far surpass anything the pigeon brain can conjure. So, on the one hand, the pigeon can do the same thing an AI can do, but it can't do it anywhere to nearly the same speed, necessarily, would be my guess as to what they're saying there. Again, pigeon versus AI. Your pigeon brain. or do we say AI has a pigeon brain? Or do we say the pigeon brain is on the level with AI? I don't know. Anyway, still, the basic process of making associations, considered a lower level thinking technique, is the same between the test-taking pigeons and the latest AI advances. You hear all the time about the wonders of AI, all the amazing things it can do, says Ed Wasserman Stewart, professor of experimental psychology in the Department of Psychological and Brain Sciences at Iowa, and the study's corresponding author. It can beat the pants off people playing chess, or at a video game, for that matter. It can beat us at all kinds of things. How does it do it? Is it smart? No, it's using the same system or an equivalent system to what the pigeon is using here. The researchers sought to tease out two types of learning. One, declarative learning, is predicated on exercising reasoning based on a set of rules or strategies, a so-called higher level of learning attributed to most people. Sorry, I thought I heard a cat jump in the background. The other, associative learning, centers on recognizing and making connections between objects or patterns, such as sky blue, water wet. Numerous animal species use associative learning, but only a select few, dolphins and chimpanzees among them, are thought to be capable of declarative learning. Yet AI is all the rage, with computers, robots, surveillance systems, and so many other technologies seemingly thinking like humans. But is that really the case, or is AI simply the product of cunning human inputs? Now, this is a point that I actually get into a little bit with ChatGPT, but it's only any AI is only so good as the data you put into it, as the data you give it. So yeah, just bear that one in mind when you're talking about it. Or as the study's authors put it, have we shortchanged the power of associative learning in human and animal cognition? Wasserman's team devised a, quote, diabolically difficult test, as he calls it, to find out. Each test pigeon was shown a stimulus and had to decide by pecking a button on the right or the left to which category that stimulus belonged. The categories included line width, line angle, concentric rings, and sectioned rings. A correct answer yielded a tasty pellet. An incorrect answer yielded nothing. What made the test so demanding, Wasserman says, is its arbitrariness. No rules or logic would help decipher the task. Aside from the rule or logic that if you get it right, you get something good. And if you don't, well, you don't. Each of the 4 test pigeons began by correctly answering about half the time, which is statistically speaking no better than guessing when you're talking about the yielding one button, hitting one button or the other. You just got a 50-50 chance if you're just guessing. But over hundreds of tests, the quartet eventually upped their score to an average of 68%. The pigeons are like AI masters, Wasserman says. They're using a biological algorithm, the one that nature has given them, whereas a computer is using an artificial algorithm that humans gave them. The common denominator is that AI and pigeons both employ associative learning, and yet that base level thinking is what allowed the pigeons to ultimately score successfully. If we're talking about an average of 68%, if we're talking about out of 100, that's actually not that great. So I have to ask the question of what do you call successful? If people were to take the same test, Wasserman says they'd score poorly and would probably give up. Quote, the goal was to see to what extent simple associative mechanism was capable of solving a task that would trouble us because people rely so heavily on rules or strategies. In this case, the rules would get in the way of learning. The pigeon never goes through that process. It does have a... Well, hold on a second. How do you know the rules would get in the way of learning if you didn't have something that could deal with the rules? Because the pigeon can't. It doesn't have an advanced enough brain to do that. Anyway, the pigeon never goes through that process. By their own admission, the pigeon doesn't. Anyway, pigeon never goes through that process. It doesn't have the high-level thinking process, but it doesn't get in the way of their learning. In fact, in some ways, it facilitates it. Wasserman sees a paradox in how associative learning is viewed. People are wowed by AI doing amazing things using a learning algorithm, much like the pigeon. And yet, when people talk about associative learning in humans and animals, it is discounted as rigid and unsophisticated. The study, Resolving the Associative Learning Paradox by Category Learning in Pigeons, was published online February 7th in the journal Current Biology. Study co-authors include Drew Kane, who graduated with a neuroscience degree from Iowa in 2022 and is pursuing a doctorate in neuroscience at Iowa, and Ellen Donahue, who has earned a doctorate in psychology at Iowa last year and is now a postdoctoral scholar at Cardiff University. National Institutes of Health funded the research. So, odd things funded by the National Institutes of Health as to whether or not an AI is similar to a pigeon, or a pigeon similar to an AI. Anyway, this is one of those that's in the category of why the heck did we need to know this? Because I don't honestly see the justification for it as I'm just looking at this. But in that humorous note, apparently AIs have pigeon brains. That would be the closing remark here, as far as I can tell it. Something simple and something goofy for your day. Apparently AIs have pigeon brains. But one thing I would point out with this is one of the things with the associative learning kind of stuff. It's a model, but it's a model that, with AI, it's a model that's building itself up on the fly, right? You have training data that it starts with, but then as it goes through and you get to real world experiments, it figures out, based upon that training data, it makes an educated guess, basically, at what's right and what's wrong. But then you also get into after after the fact finding out whether or not it was right or wrong. And from there, what happens with that is it starts to update its model. And that's why they get into the associative learning part with AI. You have to start with some base data that you're training it on, but you have to include more data. It includes more data as it goes along, and it's learning a little bit more with this associative learning process. But it depends upon the data, and it depends upon the model. It also depends upon the bias of whomever the person is who constructed said AI model when it comes to the language model AIs, which is what ChatGPT is. So yeah, that's just my thoughts. But apparently ChatGPT, I don't know. I'd have to look at the inner workings of it, but if it's an associative learning AI, like most advanced AIs tend to be, apparently ChatGPT has a pigeon brain. Anyway, random thought of the day. Let me know what you think. Hit the like button on the way out the door, comment on the video, share the video, subscribe to the channel, all that lovely good jazz. Until next time, I'm Adrian. Stay curious, everybody.